This is a Mendix application developed in low code that extends Teamcenter, our PLM solution. This app provides additional capabilities to manage the part material data process through an easy-to-use application that can be configured to the user's specific requirements.
This low-code application allows a program manager to collaborate with various teams to collect, review, and approve critical information on newly introduced parts in a large complex bill of material. This highly adaptable app leverages the Mendix workflow to automate the request process. It is able to download and synchronize the bill of material from Teamcenter or any other source, and will provide the proper reports and dashboards for the program manager to efficiently manage the plan behind every new part. Let's take a closer look. As the program manager logs on, the application will present the option to either look at the inbox with all open tasks or go to the programs. We have 3 programs that are actively being managed by Jane. We'll zoom into the buggy prototyping program for more details. 3 bills of materials have been included in this program, each synchronized with Teamcenter with the option to refresh. You can see that for each bill, the application has a status indicator indicating whether the requested information status caused the program item to be on time, at risk, or overdue. Let's open the first bill of material containing approximately 700 parts. Here we see the header information showing rolled up data points as well as the targeted objectives. Using the Objectives button, the program manager can adjust the target values. When we open the bill of material in 3View, we can already see which items are causing the program overdue status, as well as those items that are in the status of at risk. A double click on the part will bring up its details, which includes the bill of material details, as well as the 3D representation of the part. We can also see the attributes the program manager is managing using this particular application. Keep in mind that this is a highly adaptable application, and therefore any attribute or group of attributes can easily be added or removed, as this low-code application is entirely adaptable to your specific needs. The attributes we used here and logically grouped together by item, supplier, order, location, and usage are chosen purely for this demonstration. Each attribute can be associated with a manual entry or have the option to get the data from an external system. We have used the SAP connector in this case to allow the user to request pricing information from SAP. If no pricing information is available, the application can trigger a process in SAP and inform the user. We also configure specific attribute values to roll up to the parents. Take for example the weight attribute. With the current value, the total is 2,582 kilograms. When we change the weight of this part, which is used 8 times, the total increases. However, if we continue to increase the weight, the application will validate that increase against the target objective and warn the user that the 3,100 kilogram maximum weight has been exceeded, allowing the user to take the appropriate action. Attributes are grouped, with each group having a dedicated team as owner. The program manager can request that team to provide required information. In this case, the data is owned by the warehousing department, with Kate as the default contact person. Each request has a message for the team and is time-bound with a specific due date. The Mendix workflow will route the request to the allocated user's inbox and govern its status. The application will use the configurable tolerances to validate the due date and update the status accordingly. As we have defined the due date close to the current date, the application marked the item request as at risk. The application will now route the request using the Mendix workflow automation to Kate for further processing. Having been notified by the application, Kate can now look in her inbox and see the open tasks. Kate can now provide the requested information with a quick note to the program manager. Note that if Kate does not provide the data in time based on the due date, the program manager will be notified and the program will show an overdue status. The application will automate the routing back to the program manager, who can review, reject, or approve the submitted data. Returning to the program manager, Jane can review the note, look at the proposed data, and accept. As soon as she does, the at-risk status is removed, and the status reflects the notion that the rest of the information can continue to be requested, Let's now look at what dashboards and reports are available to the program manager to govern the large bill of material. Using the list view, Jane can see the items with each status and can search for specific parts. Using the dashboard view, Jane can quickly see how many items are overdue, at risk, and can drill down into more information. These are just two examples of how Mendix can provide flexible and user-friendly pages to help manage the large amounts of data associated with the program. With this short demo, we have shown you how this low-code application can provide the desired capabilities for a program manager to govern the large amounts of data associated with programs with large complex bill of materials during the initial program phase. This highly adaptable application provides these capabilities with a rich user experience connected to PLM and ERP without any customization of those systems, developed in low-code with Mendix.
As a program manager, I want to add master container information to each of the BOM lines next to the existing container information. We'll add this next to the Usage tab. Let's open Mendix Studio Pro and go to the domain model. Here we can find the BOM line entity, and on the right side we can find the master container entity. We'll add the new attribute master quantity with the type integer, and assign the correct association from the BOM line entity over to the master container entity. Let's make sure the access rules are set so the new attributes can be used. We'll give read-write access so the master container can be selected and the master quantity can be set. By closing the domain model, we'll be prompted to save these changes. By using the goto function and typing single, we can select the page called program_BOM_view_single. Scroll down and find the list view. And then further down, we can add a new tab for the master container information. Right-click, add widget, and then search for a layout grid. Select the full option, and this will help us organize this section. Select the single row and right-click and choose the Insert Row Below option. Repeat this to add another row. We'll drag the master quantity into the first row. In the second row, we'll add a widget again and add a reference selector. Here we'll add the associated container ID by dragging it onto the reference selector. In the last row, add a data view with master container as the data source. Ensure to select master container over association with BOM line. Deselect the autofill and click OK. In the App Explorer on the left, you'll find master container _ dimensions that you can drag into the data view. Double-click the data view and set the orientation to horizontal and the read-only style to text. Now, select the whole layout grid and select Extract Snippet. Name this snippet_master container so we can reuse this component later. Via the Edit button, go to the on-click microflow and go to the page. Add the master container tab and drag on the snippet_master container. Because we don't want the master container data to be edited from this page, on the data view, change the editability to no. Let's save our changes and rerun the app so we can see our new functionality. Sign in as the program manager, select the program BOM, select the first one and go to the list view. Here you'll see the master container tab. Let's click edit and see how this works. We can add our master quantity and select a master container, and now we can see the dimension information is automatically filled.